Hi guys, this is FK. So a lot of us programmers didn't come from a computer science background. We didn't study computer science in school, and a lot of us even it took a while before we got our hands on computers. I can remember the first time I started having a computer that I could use every time. I was already in my second year in university. Yeah, I was already in my second year in university. Though I'd used computers here and there, at cyber cafes and stuff, but I was already my second year in the university. And even with that, I could just interact with the computer as a user. It wasn't like I understood a lot of inner workings of a computer and stuff like that. So, like I said, with that background, I did mechanical engineering. A lot of people did accounting. A lot of people did banking. A lot of people did health sciences, and today they are programmers. And if you're like me, a lot of people like that struggle a lot with concepts that just get thrown at you when you are trying to study any type of programming language or a programming technology. Things like bits and bytes, memory, CPU processes, threads, multi-threading, and stuff like that, and you just feel like you start feeling a bit inadequate because there are these holes in your knowledge that it's expected that you should already know them. It's expected that you should already understand all these things before you start programming. But you still power through. Like someone like me, I still programmed for so many years before I even got to perfectly understand a lot of computer language process. I built a lot of applications. I built on the back end. I built on the front end, and I still did well. And I'm sure a lot of you listening to me right now are in that situation or have been through that situation whereby you started programming, you came from a different discipline, and now you have to just probably assume what a lot of things mean, or you had to keep going back to Google, okay, what is a process, what is a CPU cycle, what is IPC, intra-process communication, and so many computer buzzwords like that. What is mutex, what are locks and stuff like that, what are threads. So it kind of frustrates your programming journey a lot, knowing that you don't have that foundation to based on this foundation that a lot of computer science students have had, and they're just gliding, they're just rolling. They know all about memory, they know all about CPU cycles, they know all about hard disks, they know all about the operating systems, they know how the internet works, they know about networking, and so many, even if it's just at a theoretical level, because they did some computer science, they already have all this foundational knowledge, and it's helping them to quickly grab concepts that you are struggling to grab. So I had that problem, and at a point I had to look for a solution because I was reading different articles here and there. I was watching different YouTube channels. I remember I used to watch Neso Academy a lot, which is a fantastic YouTube channel if you want to learn about computer fundamentals. So I used to watch all those channels, but all the knowledge were not gathered somewhere for me, even though I found a site like Geeks for Geeks, which is also awesome. But there wasn't this resource that just gathered everything and in an orderly sequential manner, that just kind of takes me through the journey from the basics to the advanced levels, until I found this book. Until I found this book on Amazon. This book titled How Computers Really Work. This book eventually answered all my questions. Every question about memory, every question about CPU, every question about process, threads, and all those kind of buzzwords that just keep flying around. This book helped me to answer everything because it kind of takes you from the fundamentals of computers through all the electronics, how logic gates and transistors are used to solve maths, and then take you through bits and bytes and how programming languages interact with these electronics to give you the results you have, and how programming languages are translated from high-level languages to something like assembly language and then to machine code. This book helps you answer all those questions. Now, I'm just going to be running through the chapters quickly just to give you a hint of what is inside the book. If you want the book, I will definitely drop the link in the description, but let's just quickly run through the chapters. So it starts with computer concepts, just different computer concepts: what is digital, what is analog, numbering system, decimal numbering system, binary numbering system, and all that. What are bits and bytes? So it just gives you all those primers for before it starts going into computers in depth, hexadecimal stuff and all that. Then the second chapter is binary in action, which helps you to understand binary, helps you to understand digital text, ASCII encodings and stuff like that. Just how to interpret binaries, how to group them into things like bytes, into things like nibbles and stuff like that. So I think there's a nibble. There's something called a nibble, like half of a byte. I hope I'm pronouncing it right, called a nibble. So interpreting binary logic and stuff like that. So and this is one chapter I want you need to take serious. It might be really really nerdy, but computer is made up of binary. Or every computer operation is broken down into binary signals. So that's one thing you want to really put in mind if you're going to be trying to understand computers or trying to understand networks. Then from chapter 3 to 4 through 5 is all about digital electronics, how they are used to solve math and how they are used to compute logic. Then number 6 takes you into the world of memory. Takes you into the world of memory. And when I say memory, I'm talking about RAM. That's random access memory. That is where your program instructions are brought to be processed. And you also get to learn about clock cycles, which are used to coordinate the activities of computers. So chapter 6 takes you to memory. Then in chapter 7 you now get to learn deep dive topics on computer hardware. Deep dive topics on computer hardware. It's still going to revisit the main memory and also go in depth on the CPU, how the memory interacts with the CPU to make sure that your programs run smoothly. All about input and output, that's your I/O, and every type of bus communication on the computer motherboard. So chapter 8 takes you into the world of machine code and assembly language. I'm sure you've heard of assembly language. Even in web programming now, we have WebAssembly. So you get to understand what assembly language is all about and how it's translated to machine code. Also, then chapter 9 then takes us to high-level programming, because assembly and machine code are low-level programs. So it takes us to high-level programming. That's where you actually see your popular programming languages like C, like Python, PHP, and the rest. And it just helps you understand how these programs are structured and how they are compiled into assembly and then machine code. Then in chapter 10, you learn all about operating system. You learn all about operating system. You learn about the software that helps you to interact with the hardware. So you have your userland apps. That's the apps we are creating, sitting on top of the operating system, and then the operating system is sitting on top of the hardware. So the operating system is sort of like the broker between the apps that are running on your computer and the hardware, and helps them to also make use of the hardware in a secure manner. You get to learn things like user mode, which is the secure space where apps can run, and you get to learn about kernel mode, which is where you can actually interact with the sensitive things in the computer, like the memory, like the hard drive and stuff like that. So all about file system, device drivers, and so many other cool stuff. Then chapter 11 takes you into the internet. This is basically a networking chapter. It just teaches you how the internet works, all about something called the internet protocol, the TCP/IP protocol, the OSI model, and all those different layers, the transport layer, the physical layer, the network layer, the application layer, presentation layer, and all those kind of stuff, and how all those layers interact to make sure that computers can communicate from one system to another. And then in chapter 12 you get to learn about the web itself, the World Wide Web, how everything is linked, how we use DNS, and how the different types of language that can be used on the web, that's HTML, CSS, and JavaScript. And also have a very good section, a very deep dive into web servers and web browsers. So that's what chapter 12 gives you. Then in chapter 13 you get to learn about modern computing, which is just a fancy way of saying the new things, the new features that we now have in computing, especially now that computers are getting really, really powerful. For example, virtualization. We have things like virtualization, we have cloud computing, we have something called the deep and dark web, and all about things like Bitcoin, the whole blockchain technology, virtual reality, augmented reality, and just all the new stuff, all the new cool stuff, Internet of Things, and the different ways that computing has advanced, and what is the possibilities that we have in today's world. I think, is that the last chapter? Yeah, that's the last chapter. So 13 chapters of pure awesomeness. This book is going to give you everything you need to start understanding the inner workings of computing. As you can see, I bought a copy, I've read the entire thing, and I'm sure that because of the type of knowledge you're going to be getting, and how you're just going to be seeing all those closed windows that have kept you in the dark in terms of computer knowledge have been opened, and light is just shining into your knowledge. This book is something you're going to consume, and you're even going to make a reference material. So how computers really work, that is the name of the book. It is written by Matthew Justice. I think I also have another book by Matthew Justice, and it's published by No Stack Press. If you did not study computers as a course, or you study computers as a course but you need a refresher to remind you of the inner workings of computing to further help you with your programming journey, this is a book that I highly recommend. I highly recommend this book, and also I recommend it even more for backend programmers. because if you're doing UI UX or front end, sure, you will need a lot of stuff in this book, but I don't think you're going to need it as much as back-end developers. Back-end developers, especially back-end developers that don't have computer science background, really need this book. So that is the book I'm going to be sharing with you today. If you want to get a copy, you have the link in the description. And there's another video I made where I talked about 5 books that programmers, that's web developers, need to read, or just programmers. This book is also one of them. If you're interested in that video, you can check out this next. You can watch this next. Thank you. If you enjoyed this video, please remember to leave a like, subscribe, and see you in another one. Thank you.